Hello students, in this session we are going to study about the simple pendulum, and here we will find the expression for time period of the simple pendulum. So here I am drawing one simple pendulum. Let us consider the length of the string of simple pendulum is L and one bob of mass M it is given. Now since we want to oscillate this pendulum, so what we'll do, we will just displace this pendulum by one small angle, right? Suppose this is displaced by some angle theta, right? So now when we displace and simply release, what will happen? It will start oscillating about the mean position, right? So if we want to find out the time period of oscillation, what we need to find, first we will make the equation of S.H.M, right? So how we can make the equation of S.H.M, since it is angular S.H.M, so we will write the torque equation, right? For that sake, what we'll do, here first we will represent the forces acting on this bob. So mg force is acting in downward direction, right? Now in the rope there will be some tension force, let us consider it T, right? Now we will take the components of this mg. So as you can see here, this is theta, so this will also be theta, right? So the mg component along this rope, that will be mg cos theta, and mg component along perpendicular direction of this rope, that will be mg sin theta. So as here we can see कि what will be the restoring force acting on this bob, so that is mg sin theta only, right? That is mg sin theta only. So since we are taking here angular S.H.M, angular S.H.M, so we will write here restoring torque. So this force will create some torque about this point, right? So I am going to write that torque only. So tau restoring, that is restoring torque. So that will be equal to force mg sin theta multiplied by perpendicular distance from the point of rotation. So this perpendicular distance will be L itself. Now as here we can see, theta is in clockwise sense and this mg sin theta is producing the restoring torque in anti-clockwise sense. So here we will put one minus sign, right? So this is the torque equation. Now as we say, for this pendulum to perform the S.H.M, this theta should be very small. So since theta is very small, so sin theta can be approximated as theta in radian, right? So we can replace this sin theta as theta. So this restoring torque will become minus mg L into theta, right? Now as we know कि torque we can write I into alpha, where I is the moment of inertia of this bob about the point of rotation and alpha is the angular acceleration, right? So this I alpha will be equal to minus mg L into theta. Now this moment of inertia of this bob we need to write about the hinge point. Clear? So this is just a point mass, so simply we can write its moment of inertia, that is mr square. So mass of the bob is taken m, and that r means distance, perpendicular distance from about point of rotation, that is L only. So ml square into alpha equal to minus mg L into theta. Now after cancelling m from both side and one L will be cancelled, so here we can get alpha equal to minus g by L into theta, right? So this alpha further we can write alpha second derivative of angular displacement d2 theta over dt square, and this term we are taking left hand side, so it will become plus g by L into theta is equal to 0. So this we can let equation 1, right? So this is in the form of differential equation of S.H.M. So we can compare this equation with the differential equation of S.H.M in angular S.H.M, which is d2 theta over dt square plus omega square into theta equal to 0. So we can compare this equation first with equation second. So from here, by comparing, we can get this omega square equal to g over L, right? So here omega is the angular frequency, right? So omega we can get root over g by L. Now since we need to find out the time period, so time period t will be equal to 2 pi by omega, right? So omega value we will put here in this expression, so we can find time period, that is going to be 2 pi root over L by g, right? So this is the time period expression for the simple pendulum, and from here we can see that this time period is directly proportional to root over L, means length of the string, and this time period is inversely proportional to root over g, acceleration due to gravity, and it is independent of mass of the bob, means whatever mass we will take, time period will be same. If we change the length or acceleration due to gravity, so time period will change, right? So hopefully it will be clear to you. Thank you.